Today we are learning about how to factor equations involving quantities. What is a quantity? I say I'm going to... Those are inequalities. Close. No. It's not funny. Okay. No. Quantity. If somebody says, I'm going to give you a quantity of something.
Oh, a lot. An amount.
An amount. There's more than one thing, right? Okay. So, quantities is, if you notice here, x plus 3, that would be our quantity. Okay? So, sometimes if you were to look at this and they're like, factor that, you're like, probably not going to happen. Okay? But if we use substitution and I say let z equal x plus 3 and we rewrite the equation to look like this, that is totally doable. We're like, oh yeah, I can factor that. So we know that z squared minus y squared is a difference of two squares. So we factor. And then once you've factored it all the way, you then substitute back in your x plus 3 for the z's once your equation has been fully factored. So that means, how would I rewrite this now that it's been factored when I substitute back in? X plus 3 minus y and x plus 3 plus y. And that's your answer. Sometimes in here you might have like an x plus 3 minus 7. So if you had a number in here, you would want to simplify it. But if you don't, all we have is numbers and letters. You just leave it the way it is. Questions so far? Yes? Okay, so let's just see if I can say this a little differently. Okay, thank you for being quiet. So we are factoring just like we've been doing this whole unit, okay? This time, if you look at this problem right here, and they said factor this, I personally would be like, I'm not really sure how to factor that because that looks pretty confusing, okay? So what they're saying is you take whatever the quantity is. So this is something that is quantities more than one. And we're taking that and we're saying let z equal x plus 3. So wherever I see x plus 3 in the equation, I'm going to write z instead. So I'm basically taking this away and I'm writing it as z instead of x plus 3. So I write z squared minus y squared. Okay? So if there was another x plus 3 in the equation, then I would have crossed it out and put a z as well. But there was only one. Okay? And then this, hopefully you know how to factor that because that's a difference of squares, right? So then that's when you go, okay, that's z minus y and z plus y. And you always check to see if you can factor further, and I can't factor any further on this. So at this point, once you've factored as much as you can, then that's when you take your original x plus 3 and you plug it back in. Once you have finished factoring, you take it and you plug it back in. And so that's how I then get x plus 3 minus y and x plus 3 plus y. Does that clear things up a little bit? Yes or no? Yeah. Okay. All right, so let's try another one. So on example 2, what would be my quantity? Good. So we're going to write let z, and could you use like m or x or whatever? Well, you don't want to use x or y usually. But I just try to pick a variable that's not already in the equation, and most of the time z is not in an equation. So that's why I've chosen z, but you can use anything that you want. So let z equal x plus 4. And then once I decide that, what do I do?
Z squared.
We plug z in for wherever we see x plus 4, right? And if you want to, you could just kind of cross it out and put a z there, but then I would rewrite it. So we have 4z squared minus 36y squared. Very good. Always check for what? GCF. So we can take out a 4. We divide each of these by 4, and I get z squared minus
9.
good, y squared. So we have two terms. You want to check to see if they're difference of squares or difference of cubes, and these are squares, right? What can we write 9 as?
3.
Very good, 3 squared. So when we factor this, I have 4 on the outside, and then I have z minus 3y and z plus 3y. Can that be factored any further? No, so what do I do? Good. Now we're taking our x plus 4 and we're plugging it back in for our z's. So that means I have 4 parenthesis x plus 4 minus 3y and x plus 4 plus 3y. And I was noticing on some of your quizzes from yesterday that a lot of you will take out the GCF, but you'll forget to write the GCF in your answer. So whenever you have a GCF, make sure that GCF is part of your answer, okay? And also, as a reminder, you can always redo your quizzes one time. Just make sure that you show where you went wrong and you write out the work and then change it on the line or cross out your original answer and put the correct answer, okay? Yes?
How do you get zero? Is it just
Whatever the quantity is, like the whatever's in parentheses. And what I was saying is, I'm saying z, but you could say r. Right, you're just picking a variable. So I just chose z, but you could choose any letter that you want to. Okay? Are there any other questions about this before we move on? Okay. So, example 3. What's my quantity on this one?
X plus y.
Very good. So we're going to put let z equal x plus y. And again, like I said, you might want to just go here and cross this out and write a z, cross this out and write a z, and then rewrite it. So I have z squared plus 6z plus 5. And hopefully we remember how to factor. Remember that our middle number is our adding number, and our end number is our multiplying number.
It equals 5 and 1, right?
Good. The only numbers that multiply to be 5 are 5 and 1. And do 5 and 1 make 6? Yes. So when we factor this, we have x plus 5 and x plus 1. Oh, thank you. Yes, these are supposed to be z's. My apologies. Thank you, Marcus. You can have candy later. Okay, so those are z's. So the next one I'm going to pull for a popsicle stick. My question to you is, at this point, we've checked, we can't factor further. What do I do next? So the question is, what is my next step? What is my next answer? And Melanie, can you tell me?
take out the 2x plus 1?
Oh, on this one, you probably already finished it. So how do I finish this problem? Do you remember? So these are still z's, and what do I do now? Exactly, good job. We plug in the x plus y for our z's. So my final answer is something that someone's going to tell me. What is my final answer going to be, Amber? So Melanie just told me I'm plugging in x plus y for z. So what is this first parenthesis going to be? Yes, you're amazing. X plus y plus 5 is correct. And my other parenthesis, anybody, is?
X plus y plus 1.
Perfect. You guys are so smart. All right. Questions on 3. All right, moving on to example 4. Okay, first step for a popsicle stick. Somebody tell me what I'm going to do first, and it is Sarah Ledesma. Good. So she said, let z equal 2x plus 3y. Okay. What is my new equation? Amy, can you tell me what my new equation is? Z squared plus. Good. 7z minus 18. Perfect. Okay, so what are all the numbers that multiply to be 18? We have 1 and 18, and then we have 2 and 9, and anything else? 3 and 6. Good. Okay, which ones make 7?
2 and 9.
Good. 2 and 9, but which one has to be negative?
2.
2. And why is the 2 negative? Good. It makes a positive 7. Perfect. So we factor that and we get a z minus 2 and a z plus 9. Can I factor that any further? No. So, what does my final answer end up becoming? What do I do? Michael is not here. Yelazar. Close. Okay, so we're taking the 2x plus 3y and we're plugging in one for z, right? So the z goes away, so it's 2x plus 3y minus 2. There you go. Sorry, you probably can't read my handwriting. And then the other one is going to be what? Good. 2x plus 3y plus 9. Perfect. Thank you. Good. And that's my final answer. Are you guys ready to try example 5 on your own? How many of you already have the answer? Oh my goodness, you guys are quick. Perfect, great job.
I can't make that knowing. Why not?
Right on your own. Perfect. Amazing. There was too many people that got it done that were already finished with it. Perfect. Good. I'll be back. Perfect.
Doesn't make negative
Good.
1. Positive 1.
What?
3x is 2y squared.
Oh. Wow. There you go. That's better. Nice. All right, most of you got it. So first step is let z equal 3x plus 2y. This is z, z. Z squared minus 21z minus 100. Okay, remember to list all of the numbers that you're multiplying. So you have 1 and 100, 2 and 50. Can 3 anything work? No? 4 and 25, 5 and 20, 6 won't work, 7 won't work. And then let's just go to, there's 10 and 10. Okay, so which ones make 21?
25 and 4.
Good. Which one should be negative?
Negative 25.
Why? It needs to be a negative 21. Okay, so we have z plus 4 and a z minus 25. Then what do I do?
Plug in.
Good, plug it in for z. So that means we take the z out and we're substituting in the 3x plus 2y. So 3x plus 2y plus 4 and 3x plus 2y minus 25 is my final answer. You guys did a great job. Are there any questions?